Hi, today we are going to learn about scientific notation. Our goal today is I can convert numbers between standard and scientific notation. Feel free to pause this video at any point to be able to write things down or rewind it to be able to re-hear things that I say. So first off, what is standard notation? Standard notation is normal numbers. So those are things you're familiar with, right? It's the way we write these numbers, I should clarify. So for example, like the number 5, the number 361. Those are all standard notation, right? 5, 361, 1,200, okay? Just the normal way to write numbers. Well, scientific notation is a quick way to write long numbers. So what if I have the number 5,300,000? Okay, that's a pretty long number, and there are numbers even bigger than that, right? You get into the billions, you get into way more zeros. Okay, well, the directions, I'll tell you the directions, you write down the directions, but then we'll talk about it and I'll show you what they actually are. Move the decimal, so there's only one digit to the left of the decimal. Okay, well, in this number, there's an invisible decimal at the end. All of these have an invisible decimal at the very end of the number, okay? Because there's no digits after the decimal. Well, we need to move it so there's only one digit to the left. Well, right now to the left, we have 1, 2, 3, 4, 5, 6, 7 digits to the left right now. That's not what we want. So we're going to move this until there's only one digit to the left. Okay, so I've so far moved it. Now there's 1, 2, 3, 4 digits to the left. So I'm going to keep going. Now there's 2 digits to the left, so I got to keep going until right here. And now I have the number 5.30000, but when you have decimals, you don't have to write all those zeros. So I just have the number 5.3. Then it says times 10, so times 10, to the power of how many times you moved the decimal. So I moved it 1, 2, 3, 4, 5, 6 times. So to the power of 6. So you can see how if we have like 20 zeros, it's going to be faster to write this times 10 to the power of 20 than to write out all of those zeros. So let's go ahead and look at some examples of scientific notation. So for example, billion trillion, 31 trillion, 27 billion is what that number looks like, with a bunch of zeros at the end. So we know we have our invisible decimal there at the end. We want to move it so there's only one digit to the left, so on this side of the decimal. Okay, because right now there's 3, 6, 9, 12, 13, there's 14 digits. We don't want that. So we're just going to keep on moving. Move, 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 move. Now some people might think, cool, I'm going to stop here. I got past that big group of zeros. But there's still 5 digits over here. I only want 1 digit. So I'm going to keep moving. Some people might think, cool, I'm going to move here. 31, that's a nice small number, way smaller than 31 trillion. No, but there's still 2 digits. So I'm going to keep moving. There it is, 1 digit. So now I have 3.1027 000000000, but all of these zeros that are after it that have no other numbers, we don't have to write. Now this 0 we do have to write because it's a placeholder. We've got some other actual numbers there. But all these afterwards we don't have to write. So we just have 3.1027 times 10 to the power of how many times did we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We moved it 13 times. Okay, let's try another one. Invisible decimal right there. Right now there's 4 digits to the left. I don't want that. Okay, 1, 2, 3. To get that 4.500, which we don't have to write all those zeros, so it's just 4.5. 4.5 times 10 to the third, because we moved it 3 times. Now what about numbers these were giant numbers, super big. What about numbers that are super small, itsy bitsy teeny weeny decimals? Well, here's our decimal. It sure looks like there's 1 digit to the left. It feels like we should be done. But 0 is just a placeholder. We do not want 0 to be here. It's got to be a number between 1 and 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to move it, but I cannot move it the same way I've been moving all of these because that just is going to give me more zeros. So I have to move it in the opposite direction. 1, 2, 3, 4, 5, 6, 7. Now if I stop here, to the left it's still a bunch of zeros. That's not what I want. I need the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I have to move it one more time. That's the number 8. I moved it 8 times. Now I have that decimal, 7.31. And that 7 is a number that's not 0, it's not a placeholder. There's only one of them, 0.31. So 7.31 times 10 to the power of, I moved it 8 times. But if I just wrote times 10 to the power of 8, that means it's a giant number, like one of these up here. That's not what I want. I want to show that it's a teeny weeny number. So we do negative 8. Negative, we've learned in a previous lesson that a negative exponent means a fraction. Well, guess what? Fractions and decimals are the same thing. They both mean super small numbers. Okay, so our negative exponent that we know means a fraction or a decimal represents this super small number. So here we can try it again. We have this, but because there's only a 0, I know I have to move until it's not a 0. Keep going, keep going, keep going. Now I have 8. It's okay that there's nothing else after it. We could write 8.0, but because there's nothing after that 0, it is unnecessary. So we just write 8 times 10 to the power of, well, we moved it 1, 2, 3, 4, 5 spaces. But because it started as a small decimal, we have to represent that with the exponent. So our small number, our decimal number, makes it a negative 5. 8 times 10 to the power of negative 5. Okay, these are your examples. I want you now to pause the video. At the bottom of this page, there's some practice for you to do, where it's just converting back and forth between standard and scientific notation. So it's a table just like this, but some of these are blank. Please go in, fill those in. Once you're done, unpause the video, and we're going to keep moving on. I'm not going to give you the answers to the practice. That's not what I do here. But we'll keep moving on to the next page of notes. Okay, so you should have done that practice at the bottom of page 14. And now go ahead and turn the page to page 15. These are some word problems. So they tell us some information at the top. The mass of the Earth is 5.97 times 10 to the 24 kilograms. And the mass of the moon is 7.35 times 10 to the 22nd kilograms. And we've got these 4 questions. Now these are word problems. And I'll just tell you right now, everything's either add, subtract, multiply, or divide with these scientific notation word problems. So the challenge is figuring out, are you going to add, subtract, multiply, or divide? So combined means add. Okay, and then you could just in your calculator do the mass of the Earth, this whole number. I'll write it down. We might as well, right? 5.97 times 10 to the 24th plus 7.35 times 10 to the 22nd. Okay? The next one, how much larger? That also, same process with vocabulary, like how much smaller, how much different, what is the difference, how much less, how much more, any of those, how much. And that's just like saying, I've got 3 cookies and you have 12 cookies. How much more cookies do you have than me? Well, if I had 3 and you had 12, you obviously have 9 more. How do we figure that out? 12 minus 3 is 9. So subtract. And then it's the same thing. You can literally type into your calculator 10 to the power of 24, this whole entire thing, and click enter. Okay? It gives you the answer there. Okay, now here is where the challenge comes in with vocabulary. That was how much, and that's subtract. How many times? How many times right here? Larger, smaller, different, whatever. Okay? How many times larger? Well, let's draw a picture of what that means. If this is our Earth, how many times larger is the Earth than the moon? That means how many times would the moon fit inside of the Earth? Okay, it looks like a chocolate chip cookie, but I'm imagining taking the whole Earth and squeezing tiny little moons inside it. How many times would that fit inside? Well, really what we're doing is we're taking the Earth and splitting it up into chunks that are the size of the moon. What operation splits things up? divide. Okay, so that is probably one of the most challenging things right there, is how many times larger means divide. Okay, so go ahead and write that down. Divide. When you divide, you cannot do it. Oh, look at that. That is not supposed to be a plus symbol right there. Hopefully, as you were watching this, you caught on to that. That's supposed to be a minus sign right there. If you didn't catch on to it, go ahead and fix it now. Okay, so divide. You cannot just do plus or minus like you did before. There are multiple correct ways to type it into the calculator. My favorite way is just to use the fraction button. So that means you're going to type it in like a fraction, because fraction just means divide. So once you click that fraction button first, then on the top of the fraction is our first number, the earth. And on the bottom of the fraction is our second number. I guess we'll never know what it is. There we go. And then you can click enter. The reason for this is just order of operations. If we had a divide symbol and we did it just like this, then it doesn't follow correct order of operations with divide. So there you go. Fraction button makes that quicker. You can write down that answer. If it's a long number, round it to a decimal or something. All right, our last one. If the Earth rotates 1 times 10 to the 3rd miles per hour, how far does it rotate in 3.2 times 10 to the 2nd hours? There are multiple strategies to think of how to do this, but really it's just we're having it rotate over the same amount over and over and over again. Anytime we have the same number over and over and over repeated, that means we're going to multiply. Also, process of elimination, we already did add, subtract, and divide, so what's left to multiply? Sorry, maybe that's loud. Multiply. And yes, you can just type in this number times this number. The only one that's weird is that divide. So of course divide is what we're going to practice more of later on. Okay, there you go. Now, let's go ahead and just talk about things that might trick you. Okay, so converting back and forth between standard and scientific notation. The trickiest part is just remembering when do you have a positive or a negative exponent. So like a number like this, I don't even know, I'm just putting a bunch of zeros. Okay, that's a giant number. Let's move our decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 times 10 to the 11. It's a giant number, so it's positive. Whereas if I have a itsy teeny number, okay, 1, 2, 3, 4, 5, 6, 7, 3.8 times 10 to the, I can't do 7. I have to show that it's an itsy bitsy tiny number, so I do negative 7. The other thing to not be tricked by is how many, times versus how much. How much means subtract, how many times means divide. Okay, because how many times, that was how many times could I fit the moon inside the Earth? So we're splitting that Earth up into chunks of the moon. And how much bigger, how much smaller, anything like that. Okay, you got this.